Welcome to EDU World Space.
So the intensity of light at a distance of L is equal to the power in the visible spectrum over the surface area of the sphere of radius 1 meter. So surface area of a sphere is 4 pi L square. So yeah, also the intensity, the same intensity is equal to power entering the eye, let's call it PE, over the area of the pupil exposed, which is pi r square. And here we are given the diameter, so this will be PE over pi d square over 4. Now this power is different from this power, and so are the two areas. So this is the power in the visible spectrum, and this is the surface area of the whole sphere. So this power is getting distributed over this whole area, and the intensity reaching the eye is also equal to the total intensity, and this is equal to the power entering the eye over the area of the pupil, which is pi r square. So yeah, now we use this equation over here to get PE. So PE will be equal to I times pi d square over 4, and this will be equal to P over 16 d over L whole square. Now we will use equation 27.4 to calculate the number of photons. So the number of photons will be given by this energy per second divided by the energy of a photon, which is given by hc over lambda by equation 27.4. So this will be equal to, so n, which is number of photons per second, will then be equal to p lambda over 16 hc d over L square. Now we solve this equation using the values over here. Make sure you convert your units into meter for d and lambda. So we get this value to be 8.3 times 10 to the power 12 photons per second. Now for the second part B, we do the same calculation, but over here we take our L to be 1 kilometer instead of 1 meter. So we take this to be 10 to the power 3 meter now. And we do the same thing. So we find the number of photons per entering the eye per second. So let's call this n dash. So this will again be equal to, so we use this equation. Let me just put it inside this box. So yeah, so it will be p lambda over 16 hc d over L square. And let's call this L to be L dash. Now we can write this equation as hc d over L square times L square over L dash square. Now you can see that this part over here is actually n that we found over here. So we can simply use this value, and this will make our calculations much easier. So this is then 8.3 times 10 to the power 12 photons per second, or I can just write it like this, times L square was 1 meter, and so this is 1 meter square, and this is 10 to the power 3 meter square. So now we get n dash to be 8.3 times 10 to the power 6 photons per second.